Hi! Today we're going to learn how to easily set up a basic thermostat using only a DHT22 sensor, an Arduino relay module, a D1 Mini with the unicontrol, and a Node-RED dashboard. Again, this video assumes that your ESP8266 is already flashed with the most recent version of unicontrol and is connected to Wi-Fi. Start by soldering your hardware according to the schematic. If you're unsure about the quality of your power supply, we strongly recommend adding at least a 200 microfarad capacitor to the sensor to prevent freezing. In the interface, navigate to the Peripheral menu to define the pins. Choose General Output for the D1 pin and DHT22 Input for the D7 pin. Click Save to confirm. If the hardware is functioning properly, you should see the sensor readings within several seconds. Now, return to the Processes section and define the first process, managing the baseline temperature. This will be especially effective at night as long as we want the day temperature to be higher. Choose D7 as the input and select Mid-Range Deadband for the switching event. Input the desired target temperature into the midpoint bracket and enter the half-width of the deadband into the tolerance field. For the output, choose the D1 pin and enable publishing for both the input and output, allowing them to be tracked. Click Save, then repeat these steps for the day temperature process. This time, specify the time frame during which the day temperature will be active. Also, skip enabling the input publishing, as it doesn't provide any additional information. Assuming you already have an active connection to the MQTT broker, for example the Mosquito test broker, we may proceed to Node-RED. To gather the input telemetry in Node-RED, just drag and drop the MQTT in Node. Then, copy the topic from the Input Publish Info panel within the interface and paste it directly into the topic row of the node. By adding and connecting a debug node to the initial one, we can easily verify that the data is indeed flowing. Now, set up another MQTT in Node, but for the output this time. Be aware that there are two options for the output topic. The first is shared among all processes utilizing the same peripheral, while the second is specific to each process. Copy the first one. This way, we will know the actual state of the D1 pin, no matter which process toggles it. You may experiment with the on and off buttons to observe their effects on the relay and MQTT messages. To display the input temperature on the dashboard, drag and drop the text node, link it to the temperature MQTT in Node, and label it appropriately. For the output, use the switch node and connect it to the output MQTT in Node. Configure it to interpret the number 1 as an on payload and the number 0 as an off payload. Also, set it to be passive, so it doesn't respond to user input. Fiddle with the on and off buttons a bit more to ensure everything is running smoothly in both Node-RED and the newly created dashboard. To introduce remote control capabilities to the thermostat dashboard, we must add the target temperature selectors. A standard slider is an ideal choice for temperature selection. Include one into the workspace, give it a suitable label, and set some reasonable value constraints for your own convenience. Opt to send messages only upon release to minimize unnecessary data traffic. Then, drag and drop the MQTT out node, which will convey the selected values back to unicontrol, while copy-pasting the topic shown in the info panel next to the midpoint parameter in the interface. Finally, connect this node to the slider and click Deploy. Go to the dashboard, where you will see the newly added slider. Assign a value to it and verify that your selected temperature is correctly updated in unicontrol. To do this, navigate to the relevant process within the interface and click the Reload button. The updated midpoint value should be displayed immediately. Repeat the steps to create a slider for the day temperature as well. Depending on your preference, you may want to opt to retain the MQTT messages. This will make the remote control more convenient if you're exclusively controlling the parameters via MQTT messages. Additionally, setting the quality of service to 1 is a good practice for unicontrol. Once you've completed the setup, publish the flow and check your final dashboard. It should now display the current temperature, the heating relay state, and provide options to set the night and day temperatures, which will then be maintained. You'll notice that if the selected temperature is considerably higher than the current reading, the relay turns on immediately, and vice versa. To introduce some hysteresis and prevent the relay from reacting to minor temperature fluctuations, navigate back to the interface and set a positive control period. This adjustment ensures the relay is only activated once the input consistently remains on either side of the deadband for the specified duration. As a finishing touch, consider adding some cascading styles to improve the dashboard's appearance, even though it won't affect functionality in any way. Also, do not forget to properly test everything after completion. Now, enjoy your homemade device, and don't hesitate to share your creation with us. That's all for today, and see you in the next video.